Hey everybody, this is a narrative by way of voice regarding your midterm exam review. Problem one, you're just evaluating. Replacing -5 for x, y is replaced by 8, and then you follow your order of operations. And this problem, number one, you could actually do in Desmos. Type it in exactly how you see it, and then you set x equal to -5, y equal to +8. And basically, you're just doing plug and chug, and the result, after all the math is done, is 1,879. That's problem number one. Problem number two, select all the verbal translations of the expression x squared divided by 5 plus 3. Choice 2 works, the ratio of a number, squared, and 5. Division is also ratio. And then increase by, you're adding 3 to your ratio. Number 4 works because you're taking the sum of a number squared, which is x squared divided by 5, and 3. And number 5 works because a number squared divided by 5, which is the first term of the expression, plus 3. So your choices were choice 2, 4, and 5. 1 did not work because x squared is not 2 times x. Be careful. A lot of us made that mistake, thinking x squared, you're multiplying the value of x by 2. Not at all. And then 3 more than the square root. X squared, that's exponent. That's not the square root. Problem 3. Both cases, do your distribution first. Now be careful with the second half of this problem. Minus sign is for both the 2x, and +4 becomes -4. Now, the key step is, after combining them like terms, you subtract 2x on both sides. Notice how the 2x's, they knock each other out. So what will happen in the end is, you would have -8 equal to -4, but that's undefined. That cannot work. Number 4, whenever you see two proportions, do your cross multiplication or diagonal multiplication. So here, you would, in this case, would be setting 3 times 3n plus 7, so I'm going to highlight that part in blue, equal to 6 times 2n plus 5, and I'm going to highlight that in red because that represents the arrows. After that, that's just a matter of getting your variable terms on one side of the equation and your non-variables to the other. And when all is said and done, you should get an answer of n equals -17. I'm only giving you hints on these problems because on Thursday and Friday of this week, you will be doing them on your own. Number 5, be careful. Again, take care of your distribution first. Combine like terms to simplify the expression on each side. Here, I subtracted 5x on both sides, and I also added 16 to both sides. So in the end, you should have a -2x. It's greater than 12, but when you do your division, the result is x is less than -6. Now remember, we switched the inequality because we divided both sides by -2. So when you do that, that's the key step right here. And I bet some of you made that mistake of not switching your sign. So yeah, that's the important part right here, going from the greater than to the less than sign. Number 6, I'm sorry. Step 1, subtract 2w from both sides. And then step 2, you're going to divide 2 for each and every term. So in the end, p divided by 2, you're just going to leave it as 2. Then you also have -2w divided by 2, which just becomes -w. And then 2l divided by 2, 2's knock each other out. L is the only part left in the whole problem. Number 7, All you did was just add 3 to both sides. That's all you did. Plus 3, plus 3. Actually, I will move those plus 3s right here. So when you add the 3 to both sides, then you only have a 5x. 10 plus 3 is 13. Addition property of the inequality, since you did it on both sides of the equal sign. Inequality sign. Number 8, domain. Look at your x values. The x's are the key to this part of the problem. So I'm going to highlight domain, x values. Look for the x, which is 9. There, x is 5. Here, x is -2. Here. Number 9, find the 0 of the function. You replace f of x with 0. So you said 3x plus 9 equal to 0. Then you solve for x, which basically, that's a two-step equation. Your result, x is -3. So if x is -3, you could also write -3 comma 0. Your answer is either going to be x equals the number or the coordinate, or the pair coordinate. Number 10, that's an evaluation. Again, watch your substitution, watch your signs, use parentheses any and every time you replace a variable with a value. That is key here, because -3 to the third power, you have to take care of this part first. Do not multiply first. Don't multiply 3 times -3, then you have -9 to the third power. That would not be the correct move. You need to take care of -3 to the third power, which is -27. Then you multiply by another 3. That's how we get the -81. And the -5 comes along for the ride, divided by -2. This is -81 minus 5. Again, I bet you forgot about the minus sign. So you have -86 divided by -2. Negatives knock each other out. You have a positive 43 for the result. Number 11, you can set up your slope. M equals y2 minus y1 over x2 minus x1. Some of you might have just done y minus y over x minus x. I'm okay with that too. So I went with y2 minus y1. y2 is 3 minus, this is again why you need to put parentheses around your substitutions. You're substituting a -1. So what happens when you put minus negative makes the whole, this part, positive. So you're really adding 3 plus 1, which gives you 4. And 2 minus 0, 2. Simplify 4 divided by 2. Your slope is 2. So m would equal 2 for number 11. This is your final answer. If you want to also write m equals 2, I'm good with that. 12. Slope. Hint. Isolate y. Once you isolate the y, which you did here first, subtract both sides by 2x, negative 3y equals -2x plus 12, and divide each and every part by -3. As a result, you have a positive y because the -3's cancel. -2 divided by -3, that becomes a positive 2/3. Keep the x, and then 12 divided by -3 is -4. And then your slope, I highlighted the 2/3. Your slope will be 2/3. That's why I highlighted the slope once you isolated the y variable. Okay, sorry about that little. Oops, I'm trying to box my results here. So that's your slope. M equals 2/3. Save the work. Oops. Saving our work so I don't lose it for you guys. Always note, save your work any and every time you work on a computer activity. 13. Relations that are functions. Your key, x's do not repeat. That's why for 13a, doesn't work. Your x repeated. B works. Your x's do not repeat. Well, the y's repeated. That's fine. But as long as your x's are unique, no two x's are alike, you're good. C also works because vertical line test. I draw a vertical line. I'm only touching my function one time. So in the end, ta-da, that is a function. So C also works. And D doesn't work because in your domain you have two arrows from the same single value of your domain going to two different values in the range. So this was your domain. These are your x's, y's. So I put capital D, capital R for range. And I put lowercase x for your x coordinates, lowercase y coordinates. 14. Equation of the line. Your line crosses x-axis. X, y, which for graphing purposes, it would be a good idea to not only label your axes, but also label each part, like label the numbers and label your axes. So which is it, x, y? I mean, if you do that, that's going to help you immensely. As a result, our function crosses x-axis at x equals 3. So therefore, this is the equation. And then this is a vertical line. So this is if you have a vertical line, that's the only time you're going to have an x equals something. If it was a horizontal, then it's y equals something. Now 15, that was the same equation as 12. So if you rewrote equation 15 in terms of, I'm sorry about that, y equals 2/3 x minus 4. You actually did your problem. The other way you can do it, use your intercepts. Solve for your intercepts. So if x is 0, y has to be -4. So there's one of your intercepts right here. Then if y is 0, then x has to equal +6. So that's the other way you could have solved it. But we actually did enough work to where, from problem 12, where you really did not have to do much more work at all to this problem. I mean, you already had the y equals, you're already in that form, y equals mx plus b. So that's why I'm saying it's C number 12. You did the work, you did the dirty work already. But the other way is solve for intercepts. That's another way you can do it. You do it both ways, you're going to get the same result. So then that really tells me you know what you're doing. And I think you're going to do really well on the test. 16, f of -2 equals -1. -2 is your x, y is -1. So the only time that works is with C. A doesn't work because I don't even see an x equals -2 in this function. B doesn't work either because guess what? I also don't see a -2. So these guys right away are gone. And then D, you have to see, this is your x value, but it goes to y equals +3. But this guy's also eliminated because I need a y equals -1. Y equals -1 doesn't even exist. You don't see a -1 anywhere. So boom, kick that out. So by process of elimination, choice C works. Again, there's more than one way to get a correct answer. I hope this helps you use as many possible options. If you don't know, if plan A don't work, go with plan B. If plan B doesn't work, you might have to use plan C, but that's okay. 17. These problems, in the end, your goal is to write everything in terms of y equals mx plus b. So, if possible, write your equation in terms of y equals mx plus b. Sorry about that. So just a little more narration here. And then, basically, so you're already in y equals mx plus b for the first one, second one, third one. This one, you had to rearrange it where if you added y to both sides, then you have it, because this is technically y equals mx plus 3x equals y, or y equals 3x. There you go. Your plus b would be plus 0. This equation is also in mx plus b form. This one, you just had to add 3x to both sides. There you go. This one is already in form. This one, you just had to isolate y, so you're adding 1/3 x to both sides. So the results were the three equations that were circled were y equals 3x minus 2, y equals 3x minus 4. That should be a plus 4. I am sorry, I gave you wrong information on the answer case, so that is my fault, but I will fix that for you. And 3x equals y, or y equals 3x. Then this second equation and this fifth equation, again, they're perpendicular to each other because negative 1/4 is the negative reciprocal of positive 4. And these two are perpendicular because positive 1/4 is the negative reciprocal of negative 4, or I should say opposite reciprocal. 18, solve for m. I did that for you, m equals 7/3. You were told how to do that earlier. And then solve for b using y equals mx plus b. This one I think was probably the hardest problem, because in the end, you had the improper fraction. I think that's what got a lot of you. So I'm not sure if it's going to be as hard on the test, but if you can do this problem, chances are you're going to be A-okay. So we said m equals 7/3, x equals 2, y equals negative 3, and the result b is negative 23 over positive 3. So this is your overall final equation right here. So this maybe you're going to have a problem similar to this on your test. And I'm going to say, you may not have the fractions, but do be careful. And in the end, use Desmos to help you if need be. Last problem. Identify domain and range. Now, anytime you see arrows, lines going from one side, arrow to the other side, lines go on forever and ever. And again, this is your x, and this is your y-axis. So the x values are going to go forever and ever. So even though that line goes this way, that's going forever. That way it goes forever. Similarly for the y's. That's going to go down forever. That's going to go up forever. So your domain and range for this first graph, x is such that x is all real numbers. Range, y is such that y is all real numbers. Because again, the domain, your x's can be any x possible. You're going to get a value of y, and all your y values are going to be anything from positive to negative infinity. Now for the second graph, unlike the first graph, it starts and stops. So notice your domain starts at negative 1, 2, 3, 4, negative 5. And it ends at positive 1, 2, 3. And if you range, Start from the bottom. So you went 1, 2. So you went down to -2. Make that -2 more. And then you went up to -1, 0, 1, 2, 3. So your domain is -5 to +3. That's your x's. And then your range, -2 up to +3. Now, for the last graph, your domain, the x's, even though it looks like they're in a small, narrow path, these lines can go on forever and ever. So it turns out your domain is going to be all real numbers for x. That goes up all the way, that goes up all the way. But it's also going to go from left to right forever and ever. The range, on the other hand, the lowest possible value is at y equals -4. And again, label your axes. So the lowest we go is -1, 2, 3, -4. But these arrows are going to go up and up forever. So your range is such that y will be all values such that y is greater than or equal to -4. Because the graph touches at the point, it looks like -1, -4. Again, your y value is -4, and the range, we're worried about the y's.